So beyond Makefiles, talk about modern build tools and our experience with Zim. Like I mentioned, we'll kind of talk about some of the concepts behind build tools and make alternatives. And then, I'll tell a little bit about how Fugue switched from make-based builds to Zim-based builds. And we'll look at both some example Zim templates and configuration, as well as a little bit of the Zim source code. So kind of dabble in all of those different areas. So in terms of, some of the ideal characteristics of build tools, correctness, obviously. You want repeated builds to be reliable and produce the right results time after time. And if you don't have that, then you don't have much to start with. Next, fast, obviously. Any time spent waiting on builds is time wasted for the most part. And, I think people's experiences vary a lot on this front. Like, Go build, for example, often is fast, but maybe you're bringing in a third-party code base or something that's extremely large, or working in different languages, and some builds are faster than others, obviously. So a few aspects of what can make builds fast: incremental builds, so only build what's changed. That can make a huge difference. Parallelized builds, obviously, taking advantage of multiple CPU cores or farming work out to other machines. Don't repeat yourself. So I say that here in this category as like, not from a source code point of view, but with caching build systems, if somebody else has already run that build, you can pull from the cache instead of building the same thing yourself. So that's another way to get a speed up, and we'll talk a lot more about that. Good ergonomics. So is the build tool easy to use? Are the build definitions easy to read? Is there documentation, that type of thing? And then fit for your team. So does the tool support the languages and platforms you care about? Are its strengths aligned with the situation you're in? And, keep it simple, right? Like if your team does fine with some simple bash scripts, then maybe that's all you need. But like where Zim and I think some of these other modern build tools start to become applicable is for larger code bases or, more diverse builds. So I want to kind of open it up right away to you all. Does anybody want to share a build issue that you deal with and, a pain point you have in your builds that you're looking to solve?
Yeah, I'll be happy to. I've got one is common code, right? Everybody knows how Go modules works, and pointing releases and using Git and all that sort of thing can be very complicated, especially if you're using like a private repo. And I'm very curious to know how that sort of thing is handled when you go beyond the monolithic repo.
Right. Yep, that makes sense. Yeah, anybody else? So does anybody have slow builds or slow deploys, or is everybody set up pretty fast?
Our build, sorry, go for it.
No, go ahead.
I was just gonna say our build is definitely a pretty long process. We use Jenkins to run through all of our builds, especially dependent builds, but it's quite a long process. It takes way longer than we'd want it to.
And what languages are you building there?
We're building a pretty large number of different languages. Actually, I think Chris is more involved than I am. He's on my call as well, but we have, I think we have some Go modules. We have Java processes and Python.
Yep, and I think one of the interesting things for us and things I might not have expected is that, Node.js and Python builds actually can be slow depending on what you're doing, especially if, you're compiling native extensions or something like that. So despite it being, a scripting language, those builds can be slow too. Cool.
Yeah, on our side, we use the Webpack step takes forever.
Yep, absolutely. It kind of blows my mind as, you know, not being a front end developer myself, but like having dabbled in that, it's amazing how complex front end builds are now. And our team has dealt with that too. And we have Zim templates ourselves that help with this. So for example, like you can treat node modules as an artifact and have that in the cache and actually unpack an existing node modules and things of that nature. So that's something we've worked with too. Cool, thanks, Joel. I guess we already touched on this, but I think especially when you're building multiple languages, having a common way to build them all does become pretty important. Okay, so to talk a little bit about some of the new features in these more recent build tools, reusable high-level rules. So, you know, there should be an easy way to say, you know, I want to build in the standard pattern that my company has adopted. You know, I've got a Go executable or a Python web service. I just want to do that in the standard way. There should be an easy way to, you know, declare that with minimal code and just have that happen. Dependency analysis, I think, you know, one of the things we really struggled with Make, and maybe you have too, is getting chains of dependencies to execute in the right order. It's really difficult to do it correctly. And I think a lot of the modern tools basically have directed graphs between all the dependencies that you're working with and are able to handle that better. Caching already touched on just a little bit, but if your team can share a common artifact cache, you can pull already built artifacts from the cache rather than building it yourself. And you can do that in a really seamless way where you don't have to think about it. Cross compilation, you know, our team, for example, just during development, we're on Macs and targeting, you know, Linux in either AWS Lambda or Fargate. And so, you know, it's a common need to, you know, build on your Mac and ship to the cloud on Linux. And there's obviously a lot of variations there. Remote workers, so if you can offload to, you know, other hardware, a lot of the tools help with that one way or the other. Right now, well, while I was developing Zim, one of the options we played with was farming out work to AWS Fargate containers and having the builds happen there. That actually worked really well. And it's pretty awesome. Like at one point, you know, we could spin up even 50 or 100 build containers in Fargate to build everything in parallel. And it's pretty neat. That's actually caching in a big way actually offset the need for that though for us. So by having a Zim cache that works really effectively, we've found that we don't need as many remote workers. Hermetic builds, so this gets to kind of having a build that doesn't rely on anything on the host machine and isn't influenced by any of that. So the builds are isolated, they declare exactly what dependencies they need, and they're not affected by the host system. And that's actually really important. And one of the ways we get that in Zim is running builds within Docker containers. You know, that's isolating them from the rest of the tools that are installed on your system. And then better CLIs. I think, you know, some of the more recent CLI tooling really is a lot better in a number of ways. Okay, so just to briefly touch on some of the, you know, well-known build tools and some of the other modern ones that may be less well-known. It's from Bell Labs. It did originate in 1976, so it's kind of impressive in a way that it's had such staying power. Bazel, Buck, and Please, they're kind of in the same family of build tools in my mind. They all have reusable high-level build rules. They all support a shared cache. And so that's kind of the family of build tools that Zim fits into now. Ninja, CMake, and Scans, I don't know if that's the right way to say Scans, but Those, you know, have a lot of good reviews too. So I know a lot of people have success with those. And then of course, there's many other language specific build tools. But like I said, Zim kind of fits into that family that Bazel, Buck, and Please fall into. Please happens to be written in Go as well. All right, so let's dive into caching. I'll explain a little bit about how this works, and then we'll see how rule keys work in Zim. So I think in that family of caching build systems, this rule key concept is shared across all of them. And it's a really simple concept, but it unlocks a lot of possibilities, and I just think it's awesome. And it's one of the reasons I chose to kind of invest my own time into building Zim out. So with rule keys, the idea is for any given build, whether it's a Go binary or a Python library or whatever it is, there's a set of inputs needed for the build. That's the source files. It's also like what version of the build tools you have installed. So kind of your tool chain, you know, the version of the compilers, any environment variables that are important. So those are the inputs to your build. If you hash those, and you know, you just derive a hash from the combined set of those, that's the rule key. And now you know, so let's run that build. You produce an artifact. We then store that artifact at an address of the rule key. So basically the rule key identifies that artifact now. And then after that point, either when you or anybody on your team goes and attempts to build the same thing, and they have the same inputs, they're going to have the same rule key. They can go look in the cache and they'll see an artifact already exists at that rule key. I'm going to pull from the cache rather than building it myself. And so that's kind of the fundamental aspect of how rule keys support cached builds. Any questions on that right off the bat? Otherwise, I'll jump into an example.
Yeah, this does bring up a question for me. One of the things that we explored in detail was the potential that any given build is a release build as opposed to semantic versioning and separating things like snapshots and not. We brought that concept down to short hash of the git commit and time of the build as the combination for the artifact as it moved through our process of QA and then to determine, you know, whether deployment or not. And I'm wondering how this caching system considers that specifically in terms of versioning beyond semantic versioning.
Right. Yeah, that's a great question. And I think in early versions of some of the work we did similar things too, where, you know, you can associate a git commit revision with artifacts and so on. I think in many ways, for us at least, rule keys and this caching system have replaced the need for that. So for us, and we may be atypical, but having the shared binary cache, you know, those artifacts work for everybody. And if this system is working right, it doesn't matter if a developer built the artifact on their box or if your build system built the artifact. If it's got the same rule key, it's going to be the same binary. And so, you know, through development all the way out to release, if you want, you don't need to differentiate, you know, these artifacts were built by a developer or these artifacts were blessed for, you know, release to production. You know, everybody's using these same artifacts throughout the whole process. And so in a way, like you're getting everybody's hands-on with the same built artifact just naturally without having to have like, you know, artifactory and blessed artifacts. An interesting aspect of this, which is a little bit academic, but it does come up in practice too. The fact that rule keys are agnostic of Git revision is actually really neat. So like you know, your Git commits can be progressing, and as long as this one artifact, as long as its inputs are not touched by any of the commits, its rule key is going to be static. And so the Git revision is really entirely independent of this. So I might be partly answering your question.
Yeah, actually, I want to touch exactly what you just said, and the specific rule or the specific reason that we brought or folded the Git commit into the process was the idea that binary artifacts are generally huge, and that we would offload them in time to keep space down in Artifactory, and basically we use Nexus as our Artifactory. And to keep that cleaned up and keep that small, because its performance seems to wane pretty quick, we wanted the ability to audit based on that version. In other words, go back and rebuild the exact same artifact. We had something in production for 2 or 3 years.
Yeah.
And then we go, well, you know, something broke, we need to rebuild it. How do we get back to it? And that was the reason we introduced that. Is that something we can do here?
I think it could help. Yeah, I know certainly from experience, like going back and needing to rebuild exactly the same thing that you produced potentially years ago can be a real challenge. Like if, you know, especially if some of your dependencies have gone away one way or another. I think, you know, making the builds hermetic, like we talked about, where all the dependencies are packaged up, say in a Docker image, could help with that. Because you know, a random Python dependency from PyPy is not going to disappear or something like that. That may help. Yeah. So yeah, it may. And I'd be interested to get more of your thoughts on it, I guess, as you see more. All right. So I will show an example of how these rule keys actually work in practice. Let's see. Okay, so you should see my VS Code. So this is kind of an example repo I set up to illustrate some of the concepts here. Under source, we've got 5 directories, which each are kind of an independent component of the system. This is multiple languages, Python, Node, and Go. At the base of the repo, we've got this .zim/templates directory. So these are all the templates we use to define kind of like the kinds of the builds. You know, these are the reuse we get from this. When you set Zim up in a repo, you can do things like Zim list components, and you see the name and the kind of each component you have in the repo. I think we're gonna just drill into this authorizer as an example. We can do things like list all the inputs used by authorizer. And so you can see to build the authorizer component, here's all the relevant source files. And so that, you know, this starts to, you know, lead towards, okay, now we know everything that is needed by that component. This goes into the rule key for that thing. And if we say, show me the key for building authorizer. So here's the hash. And, you know, if we run that multiple times, you're going to get the same answer, obviously. If we go into the authorizer source code and change any of these inputs, that hash is going to change. So we'll dive into the main.go file, you know, add a log line. And our hash changes, as you'd expect. So that's the rule key. It's really quite simple from that point of view. And Zim gives you some of these commands to help understand what goes into that key. And you can get even more information on this with this detail option. So that outputs kind of a JSON representation of what's in the key. And so, for example, you can see that each of the source files uses input, their hash is in there, the name of the component, and a bunch of other information. You really do want the rule key to encapsulate everything that component depends on. So that's source files, yes, but also the tool chain used. So if we go quickly, this is a Go Lambda, I think. So if we go to the Go Lambda Zim definition, we can see that we also include tool chain information. So Go version, so the rule key will be dependent on the Go version and the OS that you're building on. Any questions about that so far?
Yeah, what algorithm are you using for hatch?
Right now it is SHA-1, and it should probably be upgraded to SHA-256 or similar. In part, it was being consistent with what Git uses for no real reason right now. I think either having that like selectable or just upgrading it to SHA-256 would make a lot of sense.
Does it factor in like some of the environment variables that can also affect the Go build? Or and actually, I guess related to that, what if you have like CGo, which also that includes like the whole C toolchain?
Yep, good question. So environment variables right now, if you add environment entries here, foobar, that is factored in. That environment variable is going to be passed in to every build. If you opt into the Docker-based build, you know, that ends up being a -e key value passed into the Docker container. And that does factor into the rule key. Right now, there's not great support for dynamic environment variables, which to some degree, you know, you may want to try to avoid those anyways for builds to have them not be affected by dynamic variables on the system. But yeah, that's the gist of it. They can factor in. And then regarding CGo, for example, I think if you did want it to be sensitive to some part of your setup there, you'd want to consider trying to add a tool chain entry for that. You know, CGo information, and maybe there's a command where you could resolve that information and it would be incorporated into the rule key. These commands, when you're running within Docker, do execute inside the container, so they'll pick up whatever information is present there, not on the host system. Cool. All right, I'll switch back to the slides for a minute. All right, so we just did that. Talk a little bit more about our situation and what led to all this. So yeah, if you were building a SaaS, it's deployed in AWS. All our code, for the most part, is in a mono repo. So, you know, we've got Go, Python, Node.js, front end, back end, all in the same repo. We do use a handful of other repos, as you would expect to, but they're kind of out of scope, I guess, for our Zim build. Python, Go, and JavaScript are our focus here. And this is probably evident to you already, but let me just make sure I drive this point home. Zim's written in Go, and it can build Go, as I was just showing. It's not only for that, though. It's very much like agnostic of whatever build you're trying to do, just like Make is agnostic of those. We are running primarily serverless in AWS, Lambda, and Fargate. So that's kind of what we're targeting with all of our builds. And then deploying with a lot of CloudFormation stacks. And so this starts just to kind of share a little bit about the scale of the problem we're dealing with. Like, we're dealing with hundreds of Lambdas and services. And so, yeah, Makefiles for building hundreds of different components, we were just having a lot of problems with keeping them consistent, among other things. And like, while we had some Make expertise on the team, we didn't have a ton. And the syntax and all the Makefile hoops you jump through to make them reliable and consistent at scale, it's a lot of work. So yeah, we had lots of inconsistencies, and it was kind of a point of frustration and wasted time on the team. Dependency chains were impossible to deal with. If you haven't read this, it's a fun paper, Recursive Make Considered Harmful. Check that out if you haven't heard of it. Incremental builds were not really. We spent a lot of time waiting on builds, and it was hard to make them incremental and still have them be correct. Deploys too were slow. Like I mentioned, we use CloudFormation, and CloudFormation's change detection can actually be really slow itself. So, and that plus deploying, 100 plus stacks, it got to be a big waste of time too. And we touched on this, but we wanted shared artifacts, but we didn't have great experience with some of the, third-party services for artifacts, just with costs and everything else. And so, we wanted to see what else we could do on that front. So all this led to Zim, and this really is one of the key aspects for us. Like in general, for any of you, if you're thinking about adopting one of these more modern build tools, I would say take a look at Bazel, Buck, and Please, and maybe they work great for you. For us, it was a large part of the problem was we've got a lot of Makefiles, and we need to be able to migrate that to a new setup and have many aspects of that be a direct translation rather than writing new reusable build rules in some different syntax. That was a big part of what led to Zim. And then new templates that you want to use, our recipe for how to build a Python library, it just needs to be simple, right? It's a couple lines of bash scripting. It shouldn't be that complicated. Caching builds, we want to make that easy. So that's kind of what led to us prototyping Zim, and then it ended up working out, and now we've adopted it at scale. So with Zim now, we're tackling both builds for all this and deploys actually, which was a recent addition. And we can do this across our entire, web service of hundreds of different components in about a minute. So say you change one line of code, you can run Zim to build and deploy that out to, a live environment in about a minute or less. And then, obviously that depends on the service. That's kind of written with a Lambda in mind. That's relatively quick to update. And in a way it's really cool, to have a huge code base to be able to change one line of code in an arbitrary source file and say, build and deploy that. And you don't have to specify any parameters. You just say, build and deploy. Zim figures out exactly what binaries, libraries changed. You get the artifacts, and it deploys the right part of the system in production, or not in production, but in your dev account anyways. So it's kind of magical when that all works. The Zim cache is our artifact repository right now. And that works for us. It probably wouldn't work for everybody. You could pair this with an Artifactory or something like that too, I suspect. We've got around 10 base templates that are reused across many, many components. And there is a way in Zim to kind of use a base template, but then override certain parts of it that need to change. And yeah, we're just trying to, continually optimize the most common operations, since those are the ones where, speed improvements can make the most difference. Yeah, but any setup, it's not yet perfect. These are a couple of things we're still working on. We're looking to leverage Lambda layers more. We've started doing that, and it's actually working really well, and it can help your build times and deploy times even more. And then still generally consolidating things so that there's still less variation in the system. All right, so I want to jump back into the code a little bit. All right. So you kind of got to glance at these templates, but let's spend just another couple minutes on that. Let's switch to a Python one. Say you're going to be deploying like a Python Lambda in AWS or something like that. Maybe you use a base image like this that has the right packages installed. We'll incorporate the Python version and the OS version in the toolchain definition, so that factors into the rule key, so that it's clear that your artifacts are kind of platform specific. And then you can see the build rule here has two requirements. So this is a bit like a phony build rule in Make. We really just refer to other things. You refer to other rules by name here. And if you can either specify a component in the rule, or if no component specified here, then it's understood to mean the same component. So running a build on this Python Lambda will build the layer and build the handler. And that's producing two different artifacts. And so for each of those, we'll just drill into one. Declare the inputs to that step, declare the outputs to that step, and here's the recipe for how to build it. So just to, I guess, to drill into these specifics just a bit. So like the idea here is let's create a Lambda layer, which is basically a zip file with a bunch of Python packages. That's entirely derived from the requirements.txt in the components directory. We're going to create this empty directory. We're going to pip install into it, and then we're going to zip it up. And that's all there is to it. This is using a relatively new feature of Zim, which is some of these like common shell commands we support directly in the Zim syntax here. You could equally, expand out your run to do things like make dir-p build layer. That's kind of the same thing. One of the nice things about, so I should explain this aspect. Run commands, that's basically sub-processing out via bash, and it will run this. That runs inside the container if you're doing Dockerized builds. These steps, which Zim executes natively, happen on the host. One thing for us, and many of you probably are not in this situation, but like we're often doing builds on Mac, and using Docker. And Docker on Mac, the file operations are ungodly slow. And so anything we can put on the host instead of running in the container, we do. But like pip install, if you've got Python dependencies that have C extensions or something like that, you might need them to build native. And then talk about the handler. It's kind of the same thing, but we're using a glob pattern to pick up all the Python files in that component subdirectory. Name is the name of the component. So like, as an example, I think reverse here is a Python component. We can open up its component.yaml. It says, this is the name of the component, and this is my build template of Python Lambda. So that's the one we were just looking at. And so name for reverse will be reverse. All artifacts right now, and this is something we want to make configurable, I think, get put in an artifacts directory at the top level of the repo. I think it's pretty common in these new build tools to have like a separate place where the binaries go and not just pollute your source tree with them. At the same time, I think making this configurable would make a lot of sense. But like, there's a handful of environment variables that Zim injects that you can make use of. And so artifact is one of those. And so I guess, let's see, I'll run a couple commands so you can kind of see some of this working. So we can say Zim run build for the authorizer. And I forget. I made some changes here. Yeah, I should do that. I was avoiding running in Docker just for these demos. All right, Zim run build for the authorizer. I think I put the template back to its original state. And that one. Here, I'll do this. By default, it buffers up the input, and you can configure that. There's a corresponding like option in Make that you may be familiar with, like the sync output or something. And if you say output unbuffered, then you get kind of streaming output. So you can see it's building the authorizer rule, and you get kind of the commands showing that it executes, which is pretty similar to Make. This one, I think, might take 30 seconds or something. Zim is set up automatically to use shared Go module caching and shared caching on the host. So you should get speed up. Like if you build things multiple times, you're going to reuse the same Go mod cache, which does make a big difference. So any questions on that while we wait for Go build to be slow, apparently?
Have you had any experience using Zim with C++ builds? And if not, do you anticipate any like unusual problems with or caveats with that wouldn't be the case with other languages?
We haven't yet. I've done a ton of C and C++ in the past with Make. Have not had a need to do it with Zim yet. I don't see a reason why anything would be fundamentally different. You know, I think discovering your C files straightforward. I think you could translate, you know, your GCC or G++ commands fairly directly.
Yeah.
You know, I feel like a lot of those commands can take a lot of arguments and options. And if any of those are dynamic or based on conditionals, that may be where you run into the most friction. Since like Zim definitions mostly are not so dynamic.
Right. But it seems like you could, so the command line, yeah, I mean, it seems like you could essentially have something that builds your Zim file and then your Zim file, like, but I guess that kind of defeats some of the purpose. Yeah, all right.
I mean, I think one of the nice things about Zim and the YAML syntax is you can work with it programmatically.
Right.
So I do view that as a plus, and so I think that would be fitting to, you know, potentially dynamically update it or generate it or something. But yeah.
I have a question about
Yeah.
you mentioned earlier on in the conversation about workers and kind of distributing the build. What's the strategy for distributing these things, specifically like the environment? And you know, obviously sometimes those change. I mean, and what I'm envisioning is something like, I want to build for QA, I want to build for performance, I want to build for whatever, and have them go into different environments. How do you propagate these environment information, specifically when you get into sensitive information,
Yeah,
like keys or secrets or what have you?
right. So our experience, at least, and this only became evident after making the switch to Zim or in the process. You know, we had Makefiles for our components that kind of handled builds, and the deploy stuff was kind of in there too. And there were separate build rules, but kind of all the build and deploy stuff was a little bit mixed up, and it wasn't clear what was needed for what. Our experience has been that all the dynamic things were primarily relevant at deploy time. And all the build things were actually quite static for us. And, you know, we're targeting one platform, so we don't have a lot of conditional logic around, you know, for this platform, do this, for that platform, do something else. So for us, mostly static build templates worked just fine. And most of the dynamic nature of things was relevant at deploy time. So like secret management, I think you mentioned, was relevant at deploy time, which meant the Zim builds didn't care one way or the other. For aspects of your build step that are dynamic, some of it I suspect you could capture with what Zim does today. Like I mentioned, we do have that environment option where you can specify variables that get fed in. That at the moment doesn't support anything dynamic, although that could be an easy improvement, the make equivalent would be doing something like, shell, whatever, some command. And then you can inject dynamic environment variables in. So I think maybe that's what comes to mind is like a trivial Zim enhancement that could help with that situation.
So in my mind, I'm thinking about this replacing from the perspective of replacing Jenkins, right? When we do a pipeline, you have all these builds that have to pass, if you will, in order to take it to the next level, or have dependent builds based on it. And specifically, my mind would be going through like performance, making sure things are within tolerance, unit testing, making sure you're fulfilling the interface, that sort of thing. Those are very dependent on the particular setup, right? But how does this play to that in terms of like the pipeline concept and failure, static checks, that sort of thing?
Yeah, and I think that gets to kind of one of the forward-looking things. I think we're probably going to run out of time to look at source code, so I'll share the source code with y'all. It is open source, you may have already seen it. But one of the forward-looking questions that I'm often thinking about is, should Zim be primarily focused on builds, or is it actually like a more general purpose workflow management tool? I started out with the position that, I want to make Zim work for builds, do one thing, do it well. And the dependency graph resolution works great. And we kept running into situations where it was like, well, we could actually extend Zim, use it for some of these workflows, use it for deploys, and leverage its dependency resolution and kind of the dependency graph aspect of it, and do that in a really easy way. And it's actually kind of snowballed so that we are using it for deploys now, and it works great. And so I think many of the things you do in like a Jenkins pipeline or something like that, you could translate into a graph of Zim rules that execute. And I think that would work great. So yeah, I think that would be an interesting thing to play with. I mean, ourselves right now, we're using Zim, locally, but also we use Circle CI. And so we still have Circle CI workflows that run unit tests, integration tests, builds, and some of those use Zim and some don't. So there's nothing wrong with like having Zim embedded in Jenkins or Circle CI or something else. But potentially, if it's working for you, you could have Zim's responsibilities grow and, simplify a Jenkins pipeline and have more of it handled in, the Zim directed graph of jobs that it's running.
Travis, or sorry, Curtis, you mentioned dipping your toe in the water for deploys and then like committing that way. Have you thought about extending to testing as well? I know you mentioned that is a possibility, but I was wondering about any of your personal experience with that.
Yeah, we right now, and this is an aspect I wanted to cover, and we might not have much time, but one of our attacks has been, I never want to break any of the tooling that the team has in place, right? Like you want to get a new system up and running in parallel, working pretty close to perfect, and then have people switch over. So we did that with builds, like got the Zim build working perfectly, migrated to that. Unit tests and like integration tests are kind of in a state right now where they're supported both in Zim and Make. And it works fine. It's really quite similar in many ways. I think like Zim is already helping making our unit test and integration test definitions consistent, and not having to update Makefiles in a bunch of places. So that's working well. We haven't switched to it fully yet. Yeah. So we've just got a couple minutes left, but you know, you all submitted a few questions that I wanted to have time to get to a little bit. And I think we have touched on some of these. It was asked, you know, what's our plan and roadmap to kind of a version 1 of Zim? And I wanted to actually turn that back on you all and kind of ask you all, what do you think should be in Zim 1.0 based on what you've seen? Like, are there any aspects of this that look valuable to you, but you think you might need another feature, or you might need something else for your team to make use of it? Any thoughts there before we run out of time?
I personally feel like there's a lot of room for this sort of templating to be more general and to kind of take over the workflow thing.
I'm sorry,
I would like to see,
templating? You mentioned templating, but what about it?
I'm sorry, I think there's a lot of room for templating to play more of a role in modeling and like pipelining. I find that personally, I would like, I mean, we're using Make for things that go way beyond build. And I think there's a lot of room there for that. And I would like to see a tool that's more cohesive around that sort of concept.
Right. Yeah, that makes a lot of sense. Cool. Well,
yeah, I think it'd be cool if there was callbacks for long running items, like services that run kind of a watch functionality, and you could, at the end of a watch build, you could say, hey, I have a new artifact, and submit that somehow.
Yes, I've thought about that same type of thing. And for what it's worth, we actually do have one person on our team that just started making use of Zim to start a bunch of like long running, what is it, like live reload type jobs for development tasks. And that's working really well for him. But I think like having almost like a service up that kind of builds on change and without you running a command makes a lot of sense. Yeah. Cool. Guess we're at time.
Well, awesome. Thanks so much for just kind of talking through all of that, Curtis. I know that we had a lot of questions, so we definitely can keep the conversation going in Discord. But thanks everybody for joining. I'll be looping back with some with the recording and the slide deck, that kind of thing, just so everybody can can have access to that if you're interested in looking back at it. But yeah, hope that you guys have a great day.
Yeah, thanks everybody. And please reach out if you have any questions or comments. And like I said, we didn't get to look at the source, but maybe we can chat in Discord if anybody wants to. Thanks all.
Sounds
Thank you
great.
very much.
Okay. Thanks, Curtis. Bye, everybody.